Hello, and welcome to Reading Graphs and the Information They Communicate. I'm your host, Mr. Solis. Let's go ahead and get started. Our learning objectives are the following. First, we hope to strengthen the student's ability to interpret graphs. And secondly, we want to build students' capacity to differentiate what the graph looks like and what the graph says. Here's a quick first look at graphs just to reacquaint ourselves with its parts. It's got two axes, one running vertically and one running horizontally, with information about the graph. It can also take the shape of a bar or a line graph. To begin, we're going to take a look at line graphs, especially how they look when put into a graphing calculator. The first we'll be looking at is y equals x, and hopefully you have a graphing calculator handy. If not, there's no need to fear. The website below actually has a great graphing calculator for you to use, and it has all of the same parts that we'll be working with today. It has a place for you to input the equation, as well as a place for you to change the window, which is really what we want to see today. How does changing a window affect the way the graph looks on the graphing calculator? To begin, we input our graph's equation, which you can do so by hitting the y equals button on the lower left-hand corner of the screen. And we're just going to type x in the first y equals field. If you're using that website, all you have to do is select the equation at the top of the screen and do the same. We want y equals x to begin with. Next, select the window button, the second button underneath the screen, and input the following values. You can do this on the website I shared before by going to the top of the screen under the phrase Graphing Calculator and selecting Settings. Finally, select Graph, the last button under the screen, and it should give you a picture similar to what we see here. Here's what I got inputting y equals x into the Graphing Calculator app on my iPad, and generally they look the same. Now we're going to see whether or not the graph changes if we change the x min and x max value in our window. Go back to where we input our window values and change the x min and x max to -50 and 50. Pause the video and take a look at what the graph looks like. Feel free to go back and change the x min and x max to anything you'd like and see what it does to the graph. So go ahead and pause it, and I'll see you back here when you're ready. Welcome back. To refresh our memory, here's our original equation and window. And here's our equation with our new window, with x running from -50 to 50. Notice any differences? The line appears to be moving up much faster, and it looks to be in a completely different direction. It's important to note, however, that the two lines are exactly the same. It's only how they're being presented that makes them appear different. Take a look at where x equals 5. The equation, thus, would equal 5, since y equals x, and the point 5,5 must exist on our line, and it does. It seems higher than usual because the x-axis is divided up into different equal parts. Here are the two graphs side by side. Note the different unit values on the x-axis. In our original graph to the right, each unit was equal to 1, while on the left, the units are changed. This happened because we changed the x min and x max in our window. Because we wanted the graph to go further out, up to -50 and 50 on either side, it has to fit more information into the screen. Note that we only changed the x values in our graph. What do you think would happen if we changed the y values as well? Suppose we put the y values to go from -50 to 50 as well. Feel free to explore that one on your own. And explore these other graphs too, changing the x min and x max like we have before to see the different results. Go ahead and pause the video and explore the equations shown here. If you've never dealt with sin x or other trigonometric functions, there's no need to fear. Go ahead and type it in as you would any other equation and see what you get. It's a pretty neat graph and an excellent introduction to what you'll be dealing with in later classes. When we come back, we'll take a look at these graphs and what happened to them when we changed their window, and we'll take a look at graphs outside of the math class and how they can be misread or misinterpreted because the graph appears to be doing one thing, but it's actually doing something entirely different. Welcome back. Here's our first equation, y equals 2x minus 2, side by side with itself with its two windows. The first from negative 10 to 10, and the second from negative 50 to 50. Do you see the difference again? Much like our first equation, y equals x, the line seems to shoot up higher, faster, but in fact it's moving at the same rate, it's just a different way to see it. To illustrate the point, take a look at this. It's our graph y equals 2x minus 2 from negative 50 to 50, side by side with another graph, y equals 6x. I've made the window for y equals 2x minus 2 to be from negative 50 to 50 on the x-axis, and I've made the window for y equals 6x to be negative 10 to 10 on the x-axis, both with units of 1. What we observe is that the two equations look almost exactly alike, and that somebody not paying attention to the windows can easily mistake the left graph for 6x and vice versa. Here are the other graphs we were interested in. Y equals x squared, again, is taking on two different shapes in our different windows, but is covering the same points, regardless of what it appears to be doing at first glance. And here's y equals sine x. Sine x is interesting because the waves that it creates will continue forever on either side of the x-axis. In the second window, we asked for more of the x-axis to be shown. Thus, we got more waves, but because the screen of our calculators was the same, it has to fit them all in by making them shorter. Now I'd like to take a look at a couple of graphs that exist outside of the classroom. The first is a fun one and a favorite of mine. It's a game called Bejeweled, a Facebook app I happen to enjoy. And on the right, you'll see a graph that they give you to compare yourself and your scores with that of your friends. Here the graph shows my highest score each week for the last 5 weeks and compares them to my friend Eddie. It looks like Eddie's got me pretty beat this week, scoring almost 620,000 points, but it also looks like I've got the better of him for the last 5 weeks, beating him 3 times out of 5. What I'd like to look at more closely is the third week, because at first glance I had believed that Eddie didn't play that week at all and got a week score of 0. But upon closer inspection, it would appear as though he did play, and that it was a graph that fooled me. You see, what I thought to be 0, the bottom of the graph, is actually marked 260,000. Here they've started the y-axis at 260,000 instead of 0, because it would have made the graph harder to read if they had started 0 and hoped to reach all the way to 620,000 in such a small window. Are you familiar with any video games that might use graphs to describe a player's progress or achievements? If so, please leave a comment underneath this video. I'm very interested in what kind of examples you might have to share. I'd like you to take a moment to study this graph on your own. Pause the video and take a look at the graph and its different parts. Then when you're ready, go ahead and hit play and we'll break it down together. Welcome back. What kind of information did you gather from this graph, titled Sales of Video Games Compared to Youth Violence? What you may have deduced is that it's actually two graphs, one on top of the other, one a line and one a bar graph. Furthermore, they actually each have their own y-axis, one going from 0 to 300 on the left, and one going from 0 to 60 on the right. With that said, what kind of misconceptions or misreadings can one make while looking at this graph? Take another moment to see if there are any possibilities of making a misinformed judgment about what it's saying, and then we'll come back together and see what we find. What kind of misconceptions did you have when encountering this graph for the first time? When I first looked at it, what confused me first was knowing whether the left y-axis went with the line graph or the bar graph. I know that one of the axes represents the number of video games sold in millions, and the other represents a count of youth violent crimes recorded from 1996 to 2005, but I didn't know which one. And so for that reason, I believe that the author isn't that concerned with ascribing true values to the graphs that we're reading, but rather he wants us to take note of the trends. While the line graph is decreasing over time, the bar graph is increasing, showing an inverse relationship between the two. What kind of a message do you think the author is trying to convey with these two graphs? And what kind of a position do you think he has in regards to video games and their relationship to youth violence? Take a moment to think about it, and feel free to leave any comments or concerns in the comment section below. Now I'd like to show you a very interesting Sprint commercial which uses the bar graph to convey to television audiences everywhere that theirs is the phone service to choose from in comparison to others. I'd like you to watch the video and keep in mind what you know about bar graphs and the information they convey, and I'd like to come back and talk a little bit about their use of it for their advertisement purposes. Enjoy!
It seems everyone is saying they have the best unlimited plan. Here's the truth. AT&T and Verizon give you unlimited text and talk, but charge you extra for going over 2 gigabytes of data. T-Mobile claims they're unlimited, but use your phone a lot, and they slow down your data speed. With Sprint, you don't get charged extra, you don't slow down, and you get unlimited data, text, and calling to any mobile for only $79.99. The best unlimited plan wins.
That was neat, right? If you need to, go ahead and pause and take any notes that you care to about the commercial, or go ahead and rewind and watch it again. I'll be here to break it down with you after you're ready. Welcome back from what is probably going to be our last break, looking at our last example of graphs outside of the classroom, this one in a phone commercial. Looking back at what we did with the graphing calculator at the beginning of this lesson, what can you say about the way that Sprint is presenting this graph? Surely there are dozens of ways they could have shown this graph in the commercial, but why do you suppose they chose this particular approach? The graph is in motion, and it's moving very quickly. Furthermore, like the graph that we observed concerning violence in video games, the authors of this particular commercial seem less interested about the actual values of the graph, but more interested in the shapes that they take, and one should walk away with knowing that Sprint is above all other competitors. I hope you've enjoyed this presentation on reading graphs, and I believe with the investigations that we've made, we're more equipped to read graphs more critically in the future. If you have examples of graphs outside of the classroom that you'd like to share, or if you have any questions or comments about the ones we've seen in this presentation, please don't hesitate to submit a comment in the section below this video. Thank you very much. I've been Mr. Solis, and I hope you have a fine day.